techniques and methods of reconfigurable antennas and some simulation tools. Of course, that may not be new at all for you because all of you are here because you have some interest on antenna. I think like that. So basic interest, at least half of you, okay? So then applications. So here I mentioned a particular application which is NRCB. As Madam said, we had a collaborative work together with IG car. So this product is particularly developed for IG car. It is nuclear reaction containment building. So there is an NRCB building at IG car which is totally isolated and underground, and this antenna is particularly developed for NRCB. And the existing scenarios of patch antennas which can switch frequency and radiation pattern, and the solutions and how we improved and what is so special about. So there are a lot of pattern switching antennas, a lot of frequency switching antennas. So there should be some difference, otherwise it cannot be done recently. So what is so specific about this? And then the results and conclusion. That's how it is going to be. And as I said, there are different types of reconfigurability in antenna. So as you know, reconfigurability is capability of modifying its performance dynamically. So considering antenna, what are the reconfigurable features are? Frequency reconfiguration. You can go for multiple frequency antennas. And pattern reconfiguration, you can go for multiple patterns or multiple directions. You can have single direction antenna, you can have, as you know, like antenna radiation pattern is 360 degrees. We have 360 degrees. Any direction it can be projected. And later you might have heard about some beam steering antennas, etc. So particular direction of antenna, so pattern reconfigurability. And there can be omnidirectional antenna also, like all the 360 degrees it will transmit and receive. And polarization reconfiguration, and polarization antennas which will switch between different polarizations, and circular polarization, linear polarization, etc. And compound reconfiguration. It is simultaneously tuning several antenna parameters. So we do have a patent on this. Simultaneously switching different parameters of antenna, so that's why it's called not single parameter. So apart from this, like there could be bandwidth reconfiguration also. Not only these four, these are the general aspects which is mentioned here. Bandwidth reconfiguration also. Okay. So the uses of reconfigurable antennas depends on the application. So like as I said, like dynamically changing the frequency and pattern, like depends on the scenario. So if there is a scenario of change the frequency, you may have, as you know, like we are moving on to 4G to 5G, 5G to beyond 5G, 6G and beyond 6G communications. Recently we are with 5G and developing 5G communications. As you know, the other countries are already done with, they are utilizing 5G modulator and demodulators. Now we are in the stage of like some of the cases we also have 5G. So now 5G is not going to stay for a long. So the maximum lifetime of 5G is only 2 years. Though we spent a lot of money and a lot of research and a lot of time for 5G. So what is next is 6G and beyond 6G communications, which is in the regime of terahertz and over 90 gigahertz. So in this case, like continuous change of antennas, like different frequency bands which is necessary, which could be done by this frequency reconfigurability. And you wanted a better bandwidth or a narrow bandwidth, or you can be choosy on your region, you can be choosy on your requirements. So that's how this dynamic performance antenna works. So the method of reconfiguration, so generally all the reconfigurability, the major reconfigurable method is pin diodes or diodes, switching off with electronic reconfigurability. So by varying the effective length of the antenna, electrical length of the antenna, we call it as electrical length of the antenna. So we change the electrical length of the antenna by using the pin diodes. So that's how the reconfigurability works in most of the cases. Other than that, we may go for some parasitic directors or etc. Parasitic elements included. That's how it is, shorting pins. That's a general case for not only the frequency or bandwidth or pattern. It is for all the reconfigurable antennas. So we may say that the reconfigurable techniques are MEMS based micro electromechanical systems, are pin diodes, varactor diodes, field effect transistors. Those can be used as switching devices, or photoconductive devices also can be used, or we can alter the structure, or we can go for some liquid crystals and metasurface ferrites, etc. So we could divide this, we could say this as electrical, optical, mechanical and material change. So we work on basically a little part of the materials also. So the reconfigurability can be achieved in all these ways. Recently, this liquid crystal antennas are also a part of this and developing faster. And now, about the simulation tools, I don't have much to talk about the simulation tools. There are two kinds of simulation tools, which are CST and HFSS commonly used. Other than this also, there are simulation tools, but the commonly used tools are CST and HFSS. So HFSS is for narrowband antennas and CST is for wideband antennas. And however, these tools have, these are all finite element FEM based simulation methods, and these tools are limited to the frequency. There is an upper frequency limit also for this. We cannot go for much higher frequency for this. When we go for this terahertz and all, though it simulates, it may not be very accurate. So these tools are for lower, like maybe we could say it is 100 gigahertz or something like that. So however, still people are using this for terahertz simulations also. Now coming to my application, so I said about this nuclear reaction containment building. So when you look at this, why wireless sensor networks are implemented in this? So this building, nuclear RCB building, is located at IGGAR, which is a pride of one of the pride of India. So when you look at this, they wanted to measure temperature, humidity, turbine speed, nuclear radiation, vibration, pressure, and current of. These are the parameters which they would like to extract from the RCB building. There are different types of reactors available. As you know, a reactor where you cannot go stand and do your work there. So the reactor is a place where it has a lot of nuclear hazards, etc. So they wanted to get these parameters continuously. They wanted to monitor these parameters continuously and using the predominant standards which they can use, that is ZigBee, etc. And then the applications are a lot of applications. And then advantages, so they can be, because in a nuclear containment building, RCB building, we cannot go for a lot of wiring, and we cannot go mix wires there and place up. You know how the room will be. I do not know how many of you are aware here. So this is the place like RCB building, and it will be inside. It will be tightly packed in this way. And definitely it will go for, there is nuclear hazard, so I'm not going to much talk about this. So how the WSN is installed in this? So inside the building, many places, wherever they wanted to measure the parameters, they install wireless sensor networks. In that way, their path is like the sensor nodes, and then they will collect the raw data, and they will extract the features and then classify and identify if any problem, what is the cause of the problem, root cause.